solve. Okay, so we have looked at something similar to this example last time. So let's pick a couple more examples to use the speed and solve method and finding the inverse functions. There we go. So something similar to number 13. Let's take a look at how we can find inverse for something like this. So this is the example we're going to be looking at. So as you can see, we are given the original function f of x as 3x plus 5 divided by 7x plus 6. So the first thing we're going to do is rewrite our f of x with a y. So we will end up with y equals 3x plus 5 over 7x plus 6. So first step, replace the f of x with y. Then this is where that switch happens, right? We interchange our x and y variables. So where you see the y, we will now replace that with an x. And in the two places that we have x, we will replace that with a y. So this will now become 3y plus 5 and 7y plus 6 on the denominator. Okay. Now the idea is, since we have y in two different locations, we need to try and get the y's together, find a way to combine them. So the first thing we'll start by doing is actually take that denominator 7y plus 6 and multiply it on both sides of our equation. So we're going to multiply both sides of our equation by 7y plus 6, which will of course cancel out on the right hand side, leaving us behind with, do I want to distribute that? Yeah, I think I want to distribute that. So right now you have x times 7y plus 6 on the left and 3y plus 5 on the right. So we'll go ahead and distribute our x inside the parentheses, which will end up giving us 7xy and then 6 times x. And on the right-hand side, of course, we still have 3y plus 5. Now, like I said, the goal is to get those two y terms together so we can isolate the y. So we can actually go ahead, probably subtract the 3y, bring it to the left, and take the 6x and move it to the right. So we'll go ahead and subtract this one, move him to the right, subtract the 3y and bring that to the left. So then 3y cancels out on the right hand side, 6x cancels out on the left hand side. And we will be left with, let's see, 7xy minus 3y on the left hand side. Right hand side, we will have positive 5 minus 6x. So all we have done so far is, of course, interchanged our x and y variables. Since we have y in two places, our goal is to try and get the y together. So we multiplied our denominator by 7y plus 6. We multiplied the denominator on both sides of our equation, and then we went ahead and distributed the x, cleaned up, brought the y terms on one side, everything else to the other. Now, when I look at 7xy and 3y, we can see both of them have a y in common, which is what we wanted. So you want to factor out that common y. So bring that y outside as a common factor. So when I bring it outside, I will be left with 7x from my first term and just 3 from the second term. So you're bringing that common y outside. Right-hand side, of course, will stay as it is. And now you are ending up with y multiplied by this parenthesis, 7x minus 3. So just go ahead, divide both sides by that parenthesis, 7x minus 3. And this is how you isolate your y by itself. So this cancels out and you are now left with. Oh, I guess I'm going to put that. Over here, you have y on the left-hand side because we got rid of the 7x minus 3. And let's see, we have 5 minus 6x divided by 7x minus 3. When you get that y by itself on one side, you can now replace it with your inverse notation. And this is your inverse function for the original function that we started out with. So this one does end up looking quite a bit different than where you started out with, and that's just the nature of these rational functions that you have, where you have both x values on the top and bottom. So as I was mentioning in last class, it actually is easier to use the switch and solve method for a function like this. And then we were talking about mentally also having a shortcut method of finding inverses, but that will not really work on this example over here. So for this example, I definitely recommend using the switch and solve method. So let's go ahead. Put this answer in. So let's see. We've got. Fine. Okay, so numerator should be 5 minus 6x, denominator will be 7x minus 3. Make sure we save this image. All right. Anybody have questions on this example here? Okay. Zoom group. Okay, here's another example. And we had seen something like this when we were trying to find out if functions were one-to-one or not. With the cube roots, it's actually the same example, probably just different numbers on how to find inverses on these. So let's do the switch and solve method first, but then I'll also show you what the shortcut method on this looks like. So again, obviously replace your f of x with y. So that will end up giving us y equals cube root of x minus 7. So exact same process we did, just with different examples. Replace your x and y. So interchange those. So x comes outside. Y will go on the inside. Now again, the goal is the same here, guys. We are trying to get the y by itself. So the idea is, how do we get that y away from the cube root? So what's the first step we should do so we can get rid of the cube root? Yeah. So the opposite of a cube root function is the cube. So we will go ahead and take a cube on both sides of our equation. So the cube and cube root will cancel each other out, leaving us with, let's see, x to the third on the left. You got rid of the cube root, so just y minus 7, and then what's the last step we need to do to get the y by itself? Yeah, very nice, add the 7. So again, add that on both sides, it'll cancel out. And let's see, what are we left with? X cubed plus 7 equals y. And then again, once you get the y by itself, replace the y with your, oh, sorry, not 3, x. With the f inverse notation, and we end up getting x cubed plus 7. And that will be our inverse function. So x raised to the third power, add 7. And that looks good. Okay, well, it's not gonna let me. So this was using the switch and solve method. Now let's talk about the shortcut method. So with the shortcut method, you actually have to see in which order the operations are being done. So we start with the original function, of course, and we've got, and again, I'm just gonna use y. We've got cube root of x minus 7. So then the question is, imagine if you had the value for x given to you, what's the first thing you would do to solve your equation? Would you subtract the 7 first, or would you do the cube root part first? Cube root? Ah. It's inside the cube root symbol, right? The x minus 7. So you treat it like you would parentheses actually. So you are actually going to subtract the 7 from the x value first, and then do the cube root. So that order is really important. Now, if you did say cube root as the first operation, then your inverse function is going to come out looking completely different. Remember how with composition we were talking about if you do f of g or g of f, how that creates a new function? That's actually the same thing that will happen when you're trying to find the inverses. So if you didn't know your x value, the first thing you would have to do is subtract the 7, whatever answer you got from that, then you would do the cube root part. So that's the order you go in. Now, when you're trying to find the inverse, of course, the inverse is where you are reversing the operation, right? So addition becomes subtraction. Cube and cube root would be opposites of each other. But the other thing you have to do is also go in the reverse order. So since you were doing the cube root thing last, you would actually have to do the cube thing first. So since cube root was the last operation that happens in the original function, cube will be the first operation that happens in the inverse function, and then you subtract it by 7. So that means you would be adding 7, and this would of course be on the cube root, and you can see that's what our inverse function ended up looking like. So start by listing in what order the operations are happening, and then go in the reverse order from there. Now, as I was saying, if you were going to do, if you said, okay, I know my x value, I'm actually going to do the cube root operation first, and then add my 7, subtract, not add. And then you subtracted the 7. So when you try to find its inverse, again, you have to go in the reverse order. So going in the reverse order, we start with our x. If you say now the subtraction of 7 happened last, that means you would actually have to add 7 first. And then if the cube root happened, then you would have to do the cube. And of course, you can see that is not the function we came up with. So you really have to be careful about in which order the operations are happening. So this is the inverse. This is obviously not the inverse for this example. So that's kind of how the shortcut method works. So you don't have to do the whole switch and solve thing and all of that, but you have to be really comfortable with the shortcut method to apply that. So we'll look at a few more examples just to make sure you guys are comfortable with this. So let's take a look at what our next example is. Oh, this may be chapter 3. Let's come back here. Okay, let's look at something like this. So very similar to the example we just got done, but now you have that +5 at the end. So if we had to do the shortcut method on this one, let's talk about again in which order the operations are happening. So of course, X is always going to be our starting point. So just like we talked about, if you have X and you can see the X minus 9 is inside the square root symbol. So that means the subtraction with 9 happens first. Then you are going to do your cube root. And as you can see, the +5 is outside of the cube root, so that happens at the very end. So adding the 5 is the last thing that you're going to do. So when we reverse the order and do the opposite operations in our original for the inverse function, again, you start with X as your variable. Since we were adding 5 last, you are actually going to subtract 5 first. Then you were doing the cube root, which means we are going to do the cube function next. And then -9 was the first operation we did, so minus will become +9. So this will actually be your inverse function for this guy over here. So this is using, and I'm actually going to write it down here, I need space there. So this is going to be X minus 5 to the 3rd power +9, and this was using our little shortcut method. Now let's use the switch and solve method and see if we get the same answer, which we should. So switch and solve, of course, replace this guy with Y. Then do your interchanging of the X and Y variables. Okay, so now that you've done a couple examples with this, why don't you guys walk me through this process here? So what do we need to do? Our goal is still to get Y by itself. So what's the first step we should do? Sorry?
Subtract 5.
Yeah, get rid of the 5. So we'll start by subtracting 5, and you'll see that's exactly what happened here also. So subtracting 5 will end up with X minus 5 on the left. And then you're left with the cube root of Y minus 9 on the right. Okay, next step. You want to get rid of the cube root because the X minus 9, the whole thing is inside that cube root. So we can't deal with the 9 till we get rid of the cube root. So this is where we end up cubing both sides of our equation, and obviously cube root and cube cancel each other out. And let's see, you have X minus 5 to the 3rd power. And then right hand side, you're just left with Y minus 9. And obviously you can notice we were on the right path here. And then our last step. Yeah, just get rid of the 9, add the 9. And you are done, you get Y by itself. So we'll have Y by itself on one side, and then let's see, we've got X minus 5 raised to the 3rd power. And then we added 9, and he is our inverse function. So I would say, practice with the shortcut method, see what you're comfortable with. If you don't like it, stick with the switch and solve method because that one will work every single time. And as you can see, we did the comparison here and they both work. The first example that we did today with the rational function, obviously we want to use switch and solve for that guy, but for some of these other ones, the shortcut method should work. So like I said, use whatever you are comfortable with. And both of those will work for you. So we had talked about this briefly. There we go. Where basically, if you take the composition of inverse functions together. So if f and g are inverses of each other, and you take their composition, you actually end up with the identity function. So if you did a composition of g of f, you'll end up with x as your answer. If you reverse that composition to f of g, you would still get x as your answer. So if you did something just as simple as this guy, you know what? Let's do him. So we're going to do a composition with both of them. So we'll start out with f of g, and then we'll do second time g of f. So that means you're taking the g function and you're going to put it inside of the f function. So I'm going to take the entire g function, which happens to be 5 x to the third power plus 2. And this whole thing is going to replace the x in the f function, okay? So when we do this, our f function, of course, we have a cube root. Then we have x minus 2, and then the whole thing divided by 5. So that's just the basic definition of what the f function looks like. But now we're going to be replacing our x value with what the g function was, which happened to be 5 x to the third power plus 2. And then you start cleaning this guy up. Oh, I'm gonna run out of space. Okay, so I have cube root. And let's see, 5x to the third power plus 2 minus 2. And then the whole thing divided by 5. And it's just about whatever you can simplify, right? So in this case, you can see the plus 2 minus 2 can cancel each other out right inside, which will leave us behind with, of course, the cube root on the outside. And then let's see, 5x to the third on the top, 5 on the bottom, right? So since you have 5 on the numerator and denominator, they will also cancel each other out. And then we are left with cube root of x to the third. And of course, cube root and cube also cancel each other out. And this is what we were hoping for exactly, that you should just have an x left behind. So this is actually a good way of testing to see if the two functions are inverses of each other or not. If you do a composition and you don't get x as your answer, then you know those two functions were not inverses of each other. But if they are inverses, you will see literally we have the plus 2 minus 2. So opposite operations, you had multiply by 5, divide by 5, opposite operations. Cube and cube root, again, opposite operations, and they all canceled out nicely. So this was one way. Now we can try the other way. So g on the outside, f of x on the inside. So this guy will now take g as the outer function, f as the inside. So your cube root of x minus 2 divided by 5. Now this whole thing is going to replace the x in the g function. So this guy will come out to be, let's see, my g function is 5 x to the third power, and then plus 2 on the outside. And then replace your x with the f function, so that's the cube root inside x minus 2 divided by 5. So in this case, when you look at the parentheses part, we have cube root with all of this stuff on the inside, but then you have a cube on the outside. So that's the first cancellation that's actually going to happen, is the cube root with the cube, because everything is inside the cube root. So we cannot divide the 5, we cannot get rid of the 2's till you get rid of the cube root. So luckily, that's the first cancellation that happens. So you got rid of the cube root symbol, you're left behind with x minus 2 over 5 from that part. And then you have the multiply by 5 on the outside, and you have plus 2 at the end. Now, we are multiplying 5 inside the parentheses, so you can simplify that part first. And again, multiply by 5, divide by 5, they cancel each other out. Leaving us behind with x minus 2 from the parentheses, and then the plus 2 at the end. And as you'll see, those guys also cancel out. leaving us with good old x, which is what we were hoping to find. So either composition f of g or g of f should give you the same result of x, because that is what we say is your identity function. And if you have that, they are inverses of each other. Ricardo, Diana, did you guys have any questions on this example here, guys? No? Okay. Make this a bit smaller. And we did talk about how you can restrict the domain on your function if originally it is not one-to-one. We can restrict the domain by creating a one-to-one function. So this is kind of what they're talking about. You know, what happens when you look at the graphs of the x squared function, but you will notice we are saying x squared where your x is only greater than or equal to 0, because you don't want both sides of your parabola, right? We're only looking at one arm and then looking at the square root of x function. So when you graph them, you will see this is what it comes out looking like. And we had seen examples of this from my MATLAB last time. So that green line in the center is that identity line, y equals x. And if the two graphs come out to be mirror images of each other or reflection of each other with respect to that y equals x line, then you know they are inverses of each other. And this would only happen if we take our x square function and restrict it, you know, where we're only using x as 0 or greater than 0. Now, if I had the full parabola, then obviously he's not a one-to-one function anymore, so you wouldn't be able to do its inverse. So that's the reason why we need to restrict our domain over here. And they're saying the other thing you can actually do is pick a point on each of the lines and see if your x and y variables are being interchanged. So if you're talking about the point 2, 4, that would be, let's see, +2, +4, that would be this point over here. Now, if you replace your or interchange your x and y, that will become 4, 2. And as you can imagine, that would be the point which would be reflected over here. So you can pick points also, interchange the x and y, and you can see, again, if you wanted to talk in terms of distance, that would be the same distance from that line, y equals x. So you can kind of use that idea also. This one here was asking us to find the graph to inverse the function as square root of x plus 2 and then see what their graphs look like. So if you look at this guy, we're starting out with x first. And again, since the x is inside the square root symbol, that means we would need to add the 2 first. And then we would do the square root. So to find its inverse, you know, go in the reverse order. So the inverse for this guy would then come out to be, since you're doing the square root last, you would end up doing the square first. Since we were adding 2, you would now subtract 2. So the inverse for this function, f of x square root of x plus 2 will come out to be f. Inverse of that, sorry, will come out to be x squared minus 2. And again, if you want to use the switch and solve method to find that, you can use the switch and solve method also. So let's take a look at what these graphs would look like. Oh. All right, so the first one was square root of x plus 2. And then what did we do? X squared minus 2. So now here's what's going to happen in this guy, as you can imagine. If we're looking at square root of x plus 2, you know, that's of course this guy in the red. And then of course the x squared minus 2 is our parabola, but in this case, we would actually have to restrict our domain because this wouldn't be part of the inverse function. So we would have to get rid of this whole arm and we would say, okay, so this guy is our x squared minus 2 for x values greater than or equal to 0. So we would have to restrict that domain. And then if you wanted, draw the y equals x line, so you can see how they look like reflections of each other. And so you can see once you draw that y equals x, they definitely form mirror images of one another. I don't know how to restrict the domain in Desmos. I've never played around with them, so I just cross it out. So imagine that other arm of your parabola is not there. Okay. All right, let's save that. This is what the two graphs would end up looking like. We've got another example if you wanted to see in the notes. Now, here's where we kind of talk about the shortcut method using the mental process of solving it. So basically, the idea here would be, as they're telling you to find an invertible function that involves a single operation, you just basically use whatever the inverse function would be. So addition would be subtraction, multiplication is division, and that sort of thing. So you can see when you have an original function like 2 times x, that's multiplying the 2. So its inverse would then become divide by 2, and that becomes x divided by 2. If you have an original function of x minus 5, you're subtracting 5. Of course, its inverse would be where you are adding 5. Same thing with something like cube of x. So x to the 3rd power, its inverse comes out to be cube root of x. You can do the same thing with square root. However, you will notice for the bottom 2 functions, if your function is 1 divided by x, its inverse happens to be the function itself, 1 divided by x, and same thing with the negative x. They are inverses of each other. So these guys are inverses of each other. And if you want to verify, just use the switch and solve method, and you'll see we do in fact come up with the same answer. Actually, this also happened with us Tuesday. We had something like this, negative x minus 9, and he is his own inverse also. So these guys, end up becoming inverses of themselves. Now, if you have more than one operation, because obviously we're not only going to be dealing with a single operation, if you have more than one operation, they're telling us we find the inverse by applying the inverse operations, but you go in the opposite order from the original function. So the way they appear in the original function, we go in the opposite order. And of course, we use the inverse function. So this was just a quick set of examples. Some of them are single operations, some of them are multiple operations, but we're trying to find their inverses. So can you tell me for this first one, what the inverse is going to be? And again, Ricardo, Diana, you can share your answer with me through chat so I can make sure you guys are okay with this. So what will our inverse for the first one look like?
X over 5.
Yeah, very nice. Since we are multiplying by 5, you divide by 5 to find the inverse. Okay, part G. Was it? Oh, come on, this is there. There you go. So since you're subtracting, the inverse function would be adding x plus 88. Very nice. So those were single operations. Now here, we've got 2 operations, right? Because when we first look at x, would you multiply by 3 first or subtract the 7 first? How would you solve this? So if you knew the value for x, what would you solve first? Yeah, Ricardo, very nice on that answer. So if I gave you a number for x, let's say I gave you 1, what would you do first? Multiply by 3 or subtract 7? Multiply by 3. So the 3 is being multiplied first, and then you would subtract the 7. So remember, you have to go in the opposite order of the original function. So in the inverse function, since subtracting 7 happened last, adding 7 is going to happen first. So x plus 7. So add the 7 first. Then the multiplication with 3 happens. So its inverse would be dividing by 3. So that becomes your inverse. Yeah, exactly. What was that, Diana? Very nice. And then, so Ricardo, I know what you mean in that sense, but I would just go ahead and put the x plus 7 in parentheses, so that way we know the whole thing is being divided by 3, okay? Alrighty, awesome, very nice. Okay, this guy over here, I actually prefer to just bring my x term in the front, so I write it as negative 3x plus 4, so it kind of looks more like numbers that you had in C. And then we can kind of break it down. So same thing's happening over here with the x. The negative 3 gets multiplied first. And then you are adding 4. So go ahead and tell me what the inverse for this guy is going to be. So multiply by 3 first, then add the 4. So when you do the inverse function, what will you end up with?
Would it be x minus 4 divided by -3?
Okay, so adding 4, so that would be the opposite as -4, and then since you're multiplying by -3, you divide by -3. You can leave it like this. Mathematicians are kind of picky about where we put our negative sign, so you either put it in the numerator or in the middle of your fraction, so you can also write it like this. For some reason, we don't like leaving our negatives in the denominator. And I think a big reason for that is it's easy to forget it if you leave it in the denominator, but my math lab will accept, your answer. So as you can see, part C and D were very similar. They just wrote the D as 4 minus 3x, but you rearrange your terms and they come out looking the same. Alrighty, so I'm gonna give you guys a chance to think about E. Take your time, let me see what you come up with for the inverse of this guy. So we are given 1/2 times x minus 9. If visually it makes it better, what else can we think of multiplying by 1/2 as? Dividing by 2, right? So you can also think of that 1/2 times x as x divided by 2, if that makes it easier to find the inverse. So take your time. Let's see what you guys come up with for part E.
Oh, no, sorry, I was.
Okay. So when you divide by 1, it's actually the same as multiplying by 2. Because remember how when you are something, when you divide by a fraction, you can write that as x times and then convert it to multiply. When you have the fractions, that's what's happening. So when you're dividing by 1, it's actually the same as multiplying by 2. Okay. So it wouldn't become, because if you're dividing by 1/2, it's not the same as dividing by 2. So they wouldn't be equal. So we change that to multiplication. Yeah. Very nice. Good. So yeah, kind of what I was just wondering here. So technically, this is the same as x being divided by 2. So when you do the reverse operation, you that you will end up becoming multiplying that. So yeah, it seems like the 1/2 is the one that's creating some confusion. Okay, so you will see how you are subtracting by 9, right? So the 9 is the one that has to be added in, so he wouldn't actually become the dividend. Very nice, perfect. So just put it in front of the parentheses, and that means you're multiplying the whole term x plus 9 with that.
Okay.
So yeah, so instead of just going times 2, just put the 2 in front of the parentheses and you go to. There you go.
If you have to do the opposite, so you have to multiply this first, and you have to add another first.
Because that's what has to change with the line.
No, because we're multiplying two. Well, see, I did
So think of this as x being divided by 2. I think that's the easiest way to kind of interpret that. What do you guys have here? Okay, Ricardo, so the x plus 9 part looks good, but you're not dividing by 2, you're actually gonna multiply. So let's take a look at this one here, guys. So visually, like I said, if it helps, think of this as x divided by 2 and then the minus 9. Because when you're multiplying by 1/2, that's the same as dividing by 2. So then that means with the x, the division by 2 happens first, and then whatever answer you get, you're going to subtract 9 from it. So when you're trying to find the inverse function, since the minus 9 happened last, you add 9 first. And then, like I said, think of this as x being divided by 2. So if this x is being divided by 2, you of course end up multiplying by 2 last. The other thing that some of you were doing was thinking of this as 1/2 times x, and then you were subtracting 9. So if you're treating it like 1/2, same thing, we would have to do x plus 9 first, and then if you're multiplying by 1/2, then you end up dividing by 1/2. But remember, anytime you are dividing by fraction, it's the same thing as you take your fraction from the denominator, change division to multiplication, and then invert your fraction, and it becomes 2/1, but then it's still being multiplied, right? So you're still going to end up with 2 times the quantity x plus 9 in the parentheses. So it doesn't matter if you think of that as being multiplied by 1/2 or being divided by 2. Your final result should still come out to be the same. Question on this one, guys? And again, remember, as I was telling you before, when in doubt, use the switch and solve method, but then you won't have to worry about you multiplying by 1/2 or dividing by 2, it's the same. This guy, remember over here it's its own inverse, but just to show you how this works, you can think of this one as -1 being multiplied into x. So when we find its inverse, if I have x and if I'm multiplying by -1, then of course the opposite operation would be divide by -1, but you would still end up giving us -x. So they end up becoming their own inverse. Okay, looks like we've got 3 more examples. What time is it? Yeah, we've got time. All right, take some 5 minutes or so. Let's see what those 3 answers come out to be. You can work together if you want, you can work alone, whatever you're comfortable with. So G is talking about cube root of x minus 9, and you should notice the cube root is only on the x, right? The -9 is separate. Part H, 3 times x to the 3rd power minus 7, and then the last one is 2/3 times x over 6. And again, like I said, if you're in doubt, you're not sure, you can always try the switch and solve method. You want to try the shortcut method, that's fine too. And Ricardo, Diana, if you have any questions, you can unmute or you can just put something in chat, either way would be fine, okay? Okay, so let me ask you this. The first operation that happens on the X is what? The cube root, and then you subtract 9, right? So here, remember, you have to also do the opposite order. So since the -9 happens last, you actually add the 9 first. And then do the cube. So that's actually going to change because the order changes. Yes. Why don't we do this? It is actually that one. Oh, yeah. Is that weird? But switching it, we can do this. With the switch and solving. Because if you think about this on the X, the cube root happens first, right? And then you subtract the 9. So in the reverse one, we should be adding 9 first. And then doing the third power. I kind of wish you had erased that so I could see what you switch and solve for, right? Is that what you did, switch and solve? That's what I was thinking. Okay, so this is what happened. So you will see how your cube root, when you do the X and Y interchange, the cube root is only on Y, right? So you cannot do cube root on both sides, so you get rid of the 9. So you add the 9 first and then get rid of the cube root. That's why you guys are getting the third power only on the X and not the whole. Okay, that is. Because if the 9 was inside the cube root, then what you did would have been right. But since he is separate, you have to first move the 9 and then do the cube. Okay?
How are you doing?
Yeah, that one was good. And then this one will be the cube first, so cube root will be right. Yeah, that looks good. And then this side would be subtracted this is and then converting. Yeah, perfect, good job. Alrighty, how are you doing? That guy looks good, very nice. Did you go with the switch and solve method?
Yeah,
Okay. Yeah, that's perfect. What do you got?
I have a question on 5.
I think that guy looks good. Yeah, which one? This one?
Yeah, where I got.
So you're using measurement. Yeah, perfect. We just. You're missing because you're multiplying by 3 here, so there's gotta be a division by 3. So where did you lose your 3? You got them here. But then you didn't take them out. So you lost your division by 3 in the middle. All right, let's see, Ricardo, you've got. No, actually, Diana, it will end up being on the whole, X plus 9. Because, Ricardo, I'm kind of guessing you did the same thing as some of your classmates where you got rid of the cube root first. But since the -9 is on the outside by itself, it's not part of the cube root, you actually have to add the 9 first. And then take the cube, so the cube will actually end up going over X plus 9 and not just X. So give you guys a couple more minutes to wrap up the 3 examples and we can talk about them. Yeah.
14, you know how was it 2 and then X plus 9 was that our English term? So would it?
You could distribute it, yeah,
Alright.
definitely.
So would the 2 be correct or this one has to be the correct?
So actually, my MATLAB will take both answers.
Okay.
Yeah, so you can do either one, whichever you're comfortable with.
Okay.
Yeah.
And then you can move on with it.
Okay, so since this was originally 3 times X, it cannot stay 3 times in the inverse. The multiplication has to become division, so that will
So
actually
I
change
can divide
all of it, even the 7 actually,
Oh,
yeah. And that's kind of where, you know, that order becomes important. So that cube is actually.
But it's only the first thing we decided.
That's the very first thing you did, so that's what we're doing. And actually, since this was.
No, there's not even.
The opposite of. The cube root, right? So you can say a cube, since you already have that. as
Mhm.
it's going.
And we have.
Because you're doing the inverse operation, right? So it wouldn't stay the same as it was in the inverse operation. So the
Because you said to go to James to. You divide them.
Yeah.
So you multiply the roots, so you have to divide them.
So let's see, we have a plus six. So very first thing you're doing is multiplying your x with this fraction. And then you will have the six. So that means we will have to subtract the six first. So whichever is the last operation becomes the first operation. So you do x minus six first, and then since you're multiplying by 2/3, technically, yeah, they would divide by 2/3, right? Or as I was showing, it's just x instead of division, we do multiplication by
And then you.
so we just multiply the entire x minus six by inverse.
We used to have the three x's. We have reached the
And then your since you don't actually have the
Okay.
to make sure the whole fraction is inside.
all of it, so.
Yeah. Yeah, very nice. All right, did we get the last two done?
It's just.
What happened to them? You're still working on it? Okay, so you've done the switch at this point. Now go ahead and get the six on the other side. Yeah, very nice. And then you just left with 2/3 y, and then to move it to the other side, what would you? Okay. So now that you're dividing by a fraction, what can we do to clean it up? Yeah, so just take that and multiply by its inverse. No, turn it upside down, 3/2. So that way you don't have to worry about having a fraction in the denominator. Yeah. All right, we will already run. And then. So this guy, since originally you had the cube, right? It wouldn't stay cube because remember, yeah, it would be a cube. 3 and then put the whole fraction inside your cube. So the variables. Yeah, okay, yeah. Yeah, just make sure that the cube also unites with it. So then your last one looks good.
Did I see your last one? Oh, yeah, you saw my last one. This one's not very good.
So yeah, same thing. So since you already have the third power here, the inverse operation is cube root, right? So it's this, since this guy is a cube, this has to be cube root. So put the whole fraction in a cube root and you are done.
Oh.
All right, let's take a look here, guys. I wouldn't worry about distributing the cube, Ricardo. I would just leave it as is. And then let's see. Okay, Diana, I see your answer there. All right, guys, let's do a quick check on these guys. So the first thing that's happening on our x is the cube root. And then we subtract 9. So when you are finding its inverse, we add the 9 first to our x, and then the cube root will end up becoming a cube, and you just leave it like that, because the other thing would be to multiply into itself 3 times, right? And there's no reason to do that. So I would just leave it as x plus 9 to the third power. All right, so that was part G. Now this one over here, H, there's 3 operations that's happening. So with the very first, when you start to break this down, you are going to do the third power first. Then we multiply by the 3. And the very last thing we would do is subtract by 7. So when you're finding its inverse, starting with our x, since subtracting 7 was the last thing that happened, we would be adding 7. Then you did the 3 times, so of course multiplication becomes division. And then this one seemed to be the one where I saw most of you leaving the third power as the third power. But if you have a cube, its opposite operation is cube root, and you put the cube root on the entire fraction. Okay, so just be careful about that part. And then most of you guys did okay on I also, so of course your x is being multiplied by the fraction 2/3. And then we are adding the 6. So when you find its inverse, of course, we subtract the 6 first. Now, since you're multiplying by 2/3, technically you can divide by 2/3 if you wanted, or remember, as we had just talked about, you can also do multiply, but then invert your fraction. Or the other thing you can do is break that down. So you can think of, x is being multiplied by 2. Then we divide by 3. Then we add the 6. So when you're finding its inverse, and I'll do that here. So when you're finding its inverse, we subtract the 6 first, since you're dividing by 3. We multiply by 3, and then since you were multiplying by 2, you divide by 2, which would still end up giving you 3/2 in the front, and then x minus 6 in parentheses. So you can break that 2/3 down into 2 operations as multiply by 2 and divide by 3, and you will still get the same result. Did you guys have questions on those last two, you guys? Ricardo, Diana? Okay, let me know if you have any questions on that. What about you guys? Questions in general on this last section on inverses? No, we're good? Alrighty, so this will be the end of 2.5. Now, as I was telling you, there is section 2.6 handout in D12, but don't worry about it. I just include that because I feel like if you need to know about direct and inverse variation, it's right there if you need it for any reason. But as far as the requirements of this class goes, you're not needed to work on that. And so that's why we don't go over it. There's no homework, but the handout is just for your reference. So let's